So this is problem 33 of chapter 13 of Giancoli 6th edition. So we have a tank in the standard temperature and pressure, so STP. And so that means they are giving us the temperature and they are giving us the pressure. So let's put here the temperature, the standard for these standard conditions. The temperature means 273 kelvins, okay? And the pressure means atmospheric pressure 1 atm. Remember that 1 atm is also 1.013 10 to 5 Newton per meter square. You can also write this in kilopascal, so 101.3 kilopascal. Okay, and they tell us that this tank contains a certain amount, a certain mass, each person has a different value there, of nitrogen. Okay, that's it. The question now is, what is the volume of the tank? So this is the first question. What is the volume of this tank? Well, just let's use the equation for the ideal gas, which is PV equals to nRT. Let's see what we have here. We have the pressure, we have the temperature, the pressure, the R, right? It will depend on which unit we use, and we also have the number of moles. We also have N. How do we know that? Well, we know that in 1 mole of nitrogen N2, what we have is 28 grams. Okay, because nitrogen is 14, no? The atomic mass for nitrogen is 14, so in 1 mole we have 28 grams of nitrogen. Now they gave us the mass, this total mass, which is much bigger, this number in kilograms. So from here you can find this number of moles. Okay, so each person will get a different N there, but you have all the information. And with that, we are going to get the volume. Look that the problem is asking you to give the problem, the volume in cubic meters. So it's very convenient to use this pressure here, now in Newton per meter square, and therefore use the R in the international system, 8.315 joules per mole and Kelvin. Okay? Because then once you put all this in your PV equals nRT, you're going to get the volume already in cubic meters, so you don't need to do any transformation. Okay? So this is a good way to solve this problem. Now, part B is the following. Suppose that the volume is kept constant. They don't say that explicitly, but that's what they mean. Okay, so the volume is constant, whatever volume you got for part A, keep that number. And now they want to know what is going to be the pressure if you increase the number of nitrogen by a certain amount. So your nitrogen now is more, is a bigger M. Okay, with this bigger M, again, you're going to use the same rule that we used above to get the number of moles. Okay, and again, you're going to put this in PV equals nRT. What do we have? The volume now. We also have the temperature. This has not changed, R and N. And from here now you're going to get the pressure. Now, they want you to give the pressure in Pascal. So what you need to remember is this conversion here between Pascal and Newton per meter square. Okay, and that's it. That's how you solve this problem.